like end of the day. So end of the day, it's going to try every combination, right? Okay. Mm, Nums आ जाएगा, IDX will come, so 0, and we will call this nums, or let's say it's up this as m, so यहाँ पे m आ गया, then and that's the sum, no? Solve nums IDX, and this is the length of the entire thing, and this is the bracket. So what can we do in this case? This is going to be IDX is equivalent, and then I'll check the bracket is equivalent to 0. And how many numbers have I considered? That can be found out by this. So something like taken that is a 0. Credit 0, then I will say give the mini that's updated to minimum of service or mini and how much I have taken. Then some returning. That's it. Mini is getting updated. So the problem perfect squares. Now what can I do? For number, let's say the correct number that would be by 4 for the current number. Also, when can I go for the current number? If my target is greater than 0, that's it. That would be serve.serve. Nums would be as it is. IDX plus 1 and go, and will be as it is, and this should be equal to the target minus. So IDX, and then this will be taken plus 1 because I am taking some number. But what if I skip it, right? So I can go for the current number, and I'll be at the same index one. Yes, but I can skip that number, so that would be that would mean that then next index n will be as it is, target will be as it is. Let's say 116 लेना है, right? 114. तो 1 इसमें आ गया, then 1 इसमें आ गया, then makes sense. Target and then taking will be as it is, right? So this should end of get me closer to the answer if not right. Then did you mean meaning? Okay, so this should be okay. Output is none. Why? Because I'm not returning anything here. This is running fine. This might throw a DLE in worst case because time limit exceeded just for a number like 125. Okay, so I'll try to pick uh, for this test case 12. I can have either 444 or I can even have 9 plus 3, right? So I can have 9 then 3 times 1. So for test case like 12, sum of 444 will be fine, but I can even have something like, what do we say, 3 square is 9 plus 1, 1. Okay, no, this is not fine. I'm taking 4 numbers here, but here I'm taking only 3 numbers, and here I'm taking only 4 numbers. So 3 is better, hence they opted for this one. Okay, this is more towards greedy now. Greedily, maybe I'll pick that number. Acha, there might be a situation wherein if target is less than 0, then maybe I'll just return. Or let's say my target is equivalent to 0, then I update the answer and I return back as well. And I can say if IDX is greater than n, then I return. No, this won't work now. List is out of range as expected. So should be greater than equivalent to 1. I return. But this won't work for something like that before. Or will it? It's working. Let's submit this. Because if IDX reaches the very end, I return for 139 it's TLE. What can we do? I think we can answer here. But this three is coming after a lot of calculations, right? Because uh, there's a lot of steps involved here. And the value here, which is it can be 10 to the power 4, which is 10,000, right? Let's say 1,500. Straight up daily. Or we can just do, let's say, reverse this. Maybe that will help. No. Okay, let's see the topics: math, dynamic programming, and with first search. Okay, math, dynamic programming, and breadth first search. Okay, breadth first search हो गया क्या कि 1 से 4 I need to connect this. क्या हो सकता है? Perfect squares क्या क्या है? Let's say मेरे पास number 125 है. So what can I do with this? Perfect squares I'll have 1, 4, and then 9, then 16, 25, 36, 49, 81 आएगा ना? नहीं, 49 क्या हो गया? ये 1 2 3 4 5 6 7 8 का 64, 9 का हो गया 81, 10 का हो गया 100, एंड देन 11 का हो गया 121. So probably if I pick for 125, I pick 121 plus this 4, I'll get 125. How many numbers did I pick? Two numbers. This is something I'm getting fine. If I go here, 125, run this. Hmm. Uh, that is, so the tag here mentioned something like math तो is there, dynamic programming is there, breadth first search is there, right? तो breadth first search में मैं क्या assume कर सकता हूँ यहाँ 125 के लिए? What I can assume is, let's say I am starting from position 1. So from this position 1, I can go to any one of these numbers. 4, um, क्या रह गया? 9, 16, uh, 25, 64, and so on until something like 121. So I have this option, BFS, right? So I can go to all of it at once, at once. अच्छा, ओके ओके ओके. तो it's more like कि I have to start a BFS from every single element. That's not possible. It can be. I need to reach 125. So in my queue, so probably in my BFS queue, what will I have? I will have all the numbers inserted here. So I'll have 1, 4, 16, and then so on. 9 as well, and so on. All the numbers, all the perfect squares still less than 125, less than equal to 1. Then uh, uh, I'll remove one by one. All of them I'll remove. Uh, okay. So what is the time complexity I'm seeing here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if 125 is there, then at max the time complexity will be 11 square. Uh, so on that note, let's see what will be the time complexity if it's 10 to the power 4. Let's say if n is 10 to the power 4, it's 10,000. Then uh, which one? Then at the end I want to print the value that would be 100, right? 100. So 100 square is 101 into 101 would be 10201. That's right. So 10201, which will pass under क्या बोलते हैं 1 seconds. Yeah. So what I can do is I can have a queue here, which is this one. Let me close this. So I can have a queue in which I'll store the elements 1, 4, 9, 16, and so on until 121. Now from 1, I'll go to again all the numbers like 1, 4, 9, 16, and so on until 121. Yeah, I'll do that. Now what I can do now is, since I have been here, I will say key 1 plus 1 was 2. So can I reach, so I reach 2 in 2 steps, right? Yes. Let's say there was a use case wherein I go from 1 to 1, then 1 to 1 again, 1 to 1 again. So this kind of accounts key, I have the sum 4 in 4 steps. But what if I start from 4 only, then I can reach 4 in 0 steps, or I can reach 4 in 1 step. So this is much better, right? So I'll insert this thing into my queue again. Ah, yes. Kind of like the Chvistra's algorithm, but priority queue values. Wherein my first value will be the number of moves taken, and the second value would be the number itself. And once I hit this number to 125, I know that's the point I'll stop. Done. Yeah, I'll try that. Reset. Okay, let's try this. So I'm saying key, let's create this one. Not create, but I'll import heap queue. What else can I do? I can say heap. This is nothing but minimum heap. So heap queue is currently empty. Okay, heap is empty. Um, Inside of heap, I'll store all the elements, right? One by one. So value will be down. Or let's say I can say that square is currently number is one. So while number cut square is less than equivalent to n, in that case, inside of my heap I'll take this. So that would be heap के जगह इसको अभी simply deduct the heap. Does not matter q itself. So inside of my q I'll just add this q dot append whatever this number का square is, and then number I'll just increase it. Done. Q is done. Now I'll create the memory. So min p. So let's say min p is probably empty. Uh, heap.heapify does that, right? Or no? Yeah, it does that. Huh. So, I can do this as well. Yeah, you can make a it. So this would be what heap dot heap push heap push inside of minimum heap. I'll push in a couple of values, one and num car square, whatever that thing is, and the number I'm increasing. I don't need to declare. That's done. Now what I'll do is I'll do fs from every number. Yes. So let's say values of the thing, and in this I'll have it empty, and then यहाँ पे before including that I'll say value dot append whatever number square would be. That's it. But let's say values dot append whatever squares. Now I can say while uh, heap cube or while min, which means my min is not empty right now, then what can we do? Well, my min is not empty right now. Just one marker. Not submitted RTL add. Well, my minimum is not empty right now. I'll say the current value. I can also say let's have which kind of stores the values already visited, which would imply key hash markup here. This can be edited, and here only I'll say that it visited of this value now square equivalent to 1. That's it. Now value and the current number, that is num, is min of 0, and then I'll remove it. So that would be eq dot pop from this thing, or I can write simply get this here. Done. Value and number q dot pop minimum. Now simply go into the best minimum to the rest of the numbers. simply go in a BFS manner to the rest of the numbers. That would be for, let's say, new, or let's say this is value 1 for value 2 in values. Right? I can say new value is value 1, value 2. So I can simply say new value. Also appear with value 1, or if um, let's say number is given to n, I'm like, okay, simply return back value 1, because the very first time I reached there, right? But we'll see to this. Maybe we can return the value 1 of grade and update to get a better answer. Better answer in this sense, better minimum answer, right? So if new value is greater than n, then don't include it. That would be what? It's greater than n, not include. Simply a continue operation. Sorry, that would be continue operation. Else include it. So if I'm including it, let's say once I go to 1, so that is 2. So can I reach 2? When will I put it back into the menu? Let's say new value, if new value not in visited, in that case, if new value not in visited, in that case, I'll say this thing is equivalent to should be probability value. So it should be number 1, it should be meta, and num would be plus of 2. This should be like simply should be num, instead of num is going to be what? Value plus 1, because sure value plus 1, and I'll also take it into the minimum heap because it's not there. So minimum heap because add content, it's very simple. Heap q dot heap force, and minimum heap. I'll add it in this form, value 1, followed by whatever this minimum is. Also, I'll check key else part. If new num not in visited, but if it's already visited, then I'll check if visited or new, or let's say the current moves required, which is value plus 1. Is this better than the number of moves required earlier? If that's the case, then I'll update it with spread out. Equal to and again in this thing I'll take many I'll take whatever this thing is. I take this one and then move down. That's it. And I think so at the end of the day I just need to check if this is. I don't think so this is going to work at all because no, this is not going to work. Let's say for 125 अभी तो error आएगा बहुत सारा ना ना क्या as expected because this is never getting encountered. Acha, value 1 is nothing as such. Okay. Acha, there's again num 1 is nothing as such. Num is nothing as such, so num 1. Okay, this is running. What about 139? Is it giving me the answer faster? Yes, it is. What about 1500? Okay. The end of the day, it will reach at that point somewhere. Right? Done. Okay, let's submit this. Please. Please. Done. Okay, तो basically यहाँ पे यही था कि heap क्यों लेके like minimum heap से we have to right. Yes. Only this hint is fine, and again I think so. There's nothing as such dynamic programming here. Only DFS logic gave away the answer that minimum heap can be used here. And every single time, like this is more close to something which is like Dijkstra's algorithm. And great question. Okay, let's go to some other random groups. Let's go to B6. This looks good. I've not submitted this. Solution is also not available. Great. It's kind of like a new block. Okay, a matchbus string S consists of only 1 and 2 and obeys the following. So let's see. Okay, matchbus string will contain only 1 and 2 and obeys the following. So let's see. The string S is magical because concatenating the number of contiguous occurrences of characters 1 and 2 generates the string S itself. String S is magical because concatenating the number of contiguous occurrences of characters 1 and 2 generates the string S itself. The first few elements of S is equivalent to 1, 1, 2, 1. If we group the consecutive ones and twos in S, it will be 1, 2, 2, 1, 1. Okay, so cluster form, right? Okay, great. And then the occurrences of ones or twos in each group are okay, this is the occurrence. You can see that the occurrence sequence is S itself. Yes. Given an integer enter the ones in the first n number in the magical string S. First 6 elements of magical string S is 1, 2, 2. Okay, so this is what the magical string looks like. This is of length. Whatever this length is, let's see S का length क्या है. अच्छा, it can be 10 to the power 5. Acha, 1 2 2 1 1 2 1 1 1. Okay, so 1 2 1. Ah, this thing is following, right? 1 2 2 1 1. Excuse me. Let's say, okay. So, if I split this, then like 1 can be written as 1, 2 can be written as 2 2 1 1, then 1 can be written as 2, 1 can be written as 2, 2 can be written as 2 2, 1 can be written as 1, this can be 2 2 1 1, 2 1 1, 2 2 1 2 1 1. ऐसे ही चलता रहेगा, right? This is the pattern. Let's see, 1 2 2 1 1 2 1 2 2. Let's copy this. The same thing. See, 1 2 2 1 1. then like 2 1 2 2 1 2 1 2 2 1 double 2 1 1 2 double 2 1 1 2 फिर 1 1 2 2 1 1 1 2 1 1 1 2 ऐसे भी चलता रहता है. ओके ओके. इन दिस कैन बी 10 to the power 5. सो फर्स्ट सेगमेंट में कितने 1 है 1 1 6 में कितने हैं 1 2 3 1 4 5 6. So that's probably three ones. Yes, three ones. What if tomorrow I get n value of 10? So I go in this way. Need to see the little topics. Two pointers and string. Okay, let's go to the next one. Let's see this. Okay, it's more like houses का position दिया हुआ है, right? Houses का position दिया है, so it's like 1 2 3. There's one house here, one house here, and there's one heater here. So the radius 1, it will heat 1 3 and maybe 2 as well. Written the minimum radius standard of heaters so that the heaters could cover all the houses. Correct. Acha, okay. So, okay. I can kind of think of something. 1 2 3 4 and 1 4, right? So let's say 1 2 3 4. There's one house here, one house here, one house here, one house here. And where are the heaters? Heaters are at 1 and 4. There's one heater here and there's one heater here. What if I pick the radius as 5? Will it cover all of it? Yes. I'll reduce this. Let's say what if I pick radius of 1? Yeah, it will cover it. Right. So answer may be 1. 2 say be it will be getting covered. 1 is the answer. For this 1 5 and 2. Okay, so there's 1 5 house and the heater is at this location. Hmm. What if I straight away use a radius of 5? Will this cover? Yes. Let's close this. So answer may 5 is one of the possible answers. What if I choose 4? It will cover it. Answer is one of the possible answers 4. What if I 3? 1, 2, 3. So 3 is the answer. I get it. We can use binary search, right? That would be n log n, because log n is the heater radius and n is the house's length, or I can say heater's length. How do I determine optimally? Let's say I have houses here, 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 and here. And let's say I have heaters at this point. There's one heater here, and there's one heater here. So if I'm at the house number 1, I'll look forward to the heater which is closest to it. For example, in this case, the heater which is closest to it is this person. So I'll find the seal and the floor in this heater thing for each and every one. So what will be the time complexity? I'm going log n for that purpose to select the radius. Now I'm going inside of this, I'm going n times for all of these guys, and for that n times I'm doing a log n twice of that. So this boils down to n 2 log n ka square, which is 4n log n, just close to 4 into the 4 का log n क्या होगा, कुछ भी होगा, which is going to be somewhere close to 1024. हाँ तो should be 14, right? Close to 14. So this will be what? 16 into 10 to the power 4 into 14, which is, uh, let's assume this as 10 only. So 10 to the power 6. Which will pass in 1 second. Done. So for every single one, I have to check on क्या pass कर रहा है. हाँ, 3 pass किया इससे या इससे. Okay. Check for every one of them. अगर 3 किसी एक से ही pass हो गया, I'm good to go. Done. By the way, this is a binary search. To get the radius now I'll check if now I'll check the radius valid. That will be valid. So I'll put in mid, I'll put in whatever this length is n is, I'll put in houses and heaters. I'll put in houses and heaters. Now the thing is key. This is like the length of the house, which makes sense, or does it? So it's this. Let's have the length of heaters. I will need to compute again and again. If it's valid, then I know key minimum radius required is, let's say 10 to the power 9 and 7. Then I'll say here that my minimum radius required is met, but I need to find a better answer. Else I'm saying key, since I'm not able to find the answer, go forward, increase the radius. This is like decrease radius, and this is like increase the radius. That's it. Now let's define this function valid. Valid. Let's say my current radius is there, and whatever the process like this, meters is there. Now loop over every house and check if it's in the proximity of one of the heaters with radius equivalent to radius. So for location in houses, what I'll do is find the seal and floor here. So that would be, let's say, firstly I find the floor, which initially is -1, start would be 0, and would be n-1 because again would be m-1. That would be 1. So I'll say that simply my heaters at the current location mid is greater than equivalent to current location. In that case, this could be one of the floor values. If the current location is 3 and it's less than 100, so I know this is not really the floor, but this could be one of the possible answers. But I need a better answer. I'm saying the case simply go back like this. Okay, done. Find the seal and floor. So floor, okay. Now let's find seal. It's -1. Start with 0 and then again it's 1. And let's start if the current heater is at a greater position than the current location, then I know this is one of the possible answers, but I'll also try for better seal value. And this will be the time of a flow is equivalent to location itself. Or I can do better. Range 1 is, let's say, flow is equivalent to -1 and location, like location should be in between that, right? So I can say okay, if that's the case, and फ्लोर के पीछे का लोकेशन क्या हो गया, फ्लोर minus of that radius. Let's say currently I'm at 3, radius 2 है, 3 minus 2 is 1, 1 तक जाएगा, right? हाँ. So if it's floor minus radius is less than equivalent to location, and then this is also in between, something like floor plus radius, in that case I'm happy enough to continue. Same thing applies to C. Else I'm like, this looks super fine to me. Also, I don't need n here. So let's get rid of that quickly. Let's return limit radius. The reason being, because like n log and kind of that, right? Use example test cases. Runs fine. Submit it. I have to reduce this if it's not working. Okay, I'm getting a very huge value, but I can accommodate only this. Acha, okay. So this is not sorted, right? Heaters is not sorted. Like in this case, I see heaters is not sorted, but this is also not sorted. House is the location. That is sorted now. Let's take the same thing and paste it here. Sort, sort, sort. Done. Submit. Time limit extended. Accept it. Accept. ठीक ठीक है. 20 out of 30 test cases passed. So on two of these, I got a TLE. This is like a huge test case. Acha, I can maybe, instead of taking that 10 to the power 9, I'll simply go for, uh, what can I go for? I can go for, mm, okay, so this one. And this can be, let's say I'll copy this. No, 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 I want to copy this thing now. Copy this and paste this here. That's it. Run code. Okay, got accepted right now, but took a little while. This is an optimization. Instead of taking 10 to the power 9, first is a minus 1. That's it. Mhm. Okay, so this can be maximum of. Done. So this is like n log n, end of the day, n log n. This must be happening like binary search. Binary search. Okay. I'm done. Let's do one more. Let's go. 3, 4, 5, 6. Korean में I just need to get highest rated. तो कोरियन में highest rated कौन सा है? Kimchi and bolu. कोई नहीं. 9 is the highest rated. Hence I got kimchi. Highest rated again. Japanese. So 1, 2, 3. Like okay. So miso, sushi, and ramen. Miso, sushi, miso, sushi, and uh, ramen. So I think so ramen is the answer because 14 is correct. Okay. It's saying change rating. Okay. Change rating में क्या कर सकते हैं? Like saying sushi and 16. So I have to change sushi to 16, which means this thing gets updated to 16. Next one Japanese is called sushi is the answer. Done, done, done. Then again I have to update ramen to 16, right? Next time Japanese is called again right now the answer is 16 because this is lexicographically ramen is lexicographically smaller than sushi. Hmm. Yes, correct. Ramen is lexicographically lesser than sushi. So what will this throw me? Uh, let's say I want to question something like 10 and then sushi. Done. I want to do the same thing but with ramen. Now heap q of 0 should give me 0 should give me ramen. Oh sorry, heap of 0 of 1 should give me ramen. Beautiful, beautiful. Done, done, done. So what I'll do is again I'll use concept of heap, minimum heap. Here itself I can define it. So that would be simply min heap or better uh, varieties. Or let's say I can say something menu, the dictionary. So I just need to go over the food and the corresponding cuisines. That would be n is equivalent to length of, or I can do a zip for food, right? So for food, comma cuisine and zip of foods and cuisines. Spelling is right now. Huh? In this, I will say key in the menu, right? In the menu, or better, cuisine, not in serve dot menu. In that case, serve dot menu or cuisine. Update. Please update the answer, right? So I can say it's going to be empty. Then if you dot push eq dot push in this container. Not sure for the spelling here. Cuisine. इसके अंदर क्या पुश करना है? Push in the rating. So which is 6 would be ratings. I put in rating and whatever the next food is for this cuisine, right? Now this is the initialization part. Menu बन गया, ठीक है? Now change rating, right? Or the highest rated. Highest rated is what do we say? Quite simple. We just need to return that dot menu of that cuisine ka most element, but that secondary value. Yes. This is done. Change rating. It's a little here and there. The reason being 2 dot 10 to the power 4, right? These many calls will be done, and its length is this. So the call has to be answered in big of 1. Yes. So to keep track of something which is removed, right? Hmm. I have to change the rating now. So let's do this. In change rating, what I do is pop off from the top and store and then later on fill it up again. Okay, now I have to keep track कि अच्छा वो food किस cuisine में available है. So let's have this as menu 1. This menu 2 is a little different. Well, let's update this here. So, while self.menu1 of that cuisine is not equivalent to the code I'm looking at, and remove it. So let's store it in temp as well. Oh, yes, it did, but lexicographically smaller name. So maybe I have to do this कि इस बड़े कंटेनर में एक पर्टिकुलर कुजीन के लिए जो भी फूड वन है फूड टू है उसका रेटिंग 10 है इसका रेटिंग 10 है सो टू स्टोर समथिंग लाइक 10 के अंदर F1 F2 को have to store it using min heap. This can be stored at 10 and F1, 10 and F2 with max heap. Again, that I have to update now. I'll see you to this later. I'll just get the stream off.